most powerful event in the history of the universe wasn't an explosion. It was the Big Bang. Around 13.8 billion years ago, all space, time, matter, and energy began expanding from an extremely hot, dense state. There was no center and no edge. The Big Bang didn't happen in space. Space itself began expanding everywhere at once. In the first tiny fraction of a second, the universe underwent a period called cosmic inflation, expanding faster than the speed of light. This wasn't a violation of physics. It was space itself, stretching, rapidly smoothing and shaping the universe we see today. As the universe continued to cool, raw energy transformed into fundamental particles. Those particles combined to form atoms, which later gathered into stars, galaxies, and massive cosmic structures across billions of light years. We can still observe direct evidence of this beginning. A faint glow fills the universe in every direction, known as the cosmic microwave background. A snapshot of the universe when it was only 380,000 years old, long before stars existed. Every galaxy, every atom, and even the space between them traces its origin back to this single moment, the event that gave rise to everything.
Here's the simplest explanation of what a black hole actually is, and why it breaks the laws of physics. A black hole isn't a hole at all. It's a region of space where gravity is so strong that nothing, not even light, can escape. Most black holes form when a massive star dies. Its core collapses under its own weight until all of its mass is crushed into an incredibly tiny point called a singularity, a spot with almost infinite density. Around that point is the event horizon, the boundary of no return. If anything crosses it, light, gas, planets, even entire stars, it's gone forever. Black holes come in different sizes. Some are just a few miles wide. Others, called supermassive black holes, sit at the center of galaxies and are millions, even billions of times the mass of our sun. And even though they're invisible, we can detect them by how they warp space-time, how they bend the light of stars around them, and by the hot, glowing gas swirling into them. In simple terms, a black hole is gravity turned up so high that space, time, and physics stop playing by the rules. And we're still trying to understand how.
Astronomers found a planet lighter than cotton candy, and no one knows how it exists. Imagine a planet the size of Jupiter, but so light it could literally float on water if you could find a bathtub big enough. It's called WASP-107b, and its density is insanely low, not like a gas planet, more like a giant marshmallow in space. Planets this puffy shouldn't be able to hold themselves together. With so little mass, it should collapse like a popped balloon. But somehow it doesn't. One clue, it orbits extremely close to its star, so close that its atmosphere is boiling away into space, like steam rising from a pot of boiling sugar. Scientists believe it might be losing layers of its atmosphere every second, slowly shrinking and changing into something totally new over time. A planet made of cosmic cotton candy, melting in the heat of its own sun. Space isn't just mysterious. Sometimes it's sweet. In 2025, we discovered a comet that didn't come from our solar system. It's called 3I Atlas, and the 3I means it's the third confirmed interstellar object ever found, after Oumuamua and Comet 2 Ors-I Borisov. We know it's interstellar because of its orbit. Its path is hyperbolic, meaning it isn't gravitationally trapped by the sun. It came in, and it will leave forever. Studies show its chemistry doesn't match most local comets. It's unusually rich in carbon dioxide and likely formed around a star with different elemental ratios than our sun. At its closest, it passed about 126 million miles from the sun. That's farther than Earth, but close enough to study it. It came within about 167 million miles from Earth, safely distant yet measurable. 3I Atlas may be older than our solar system, carrying frozen material from a completely different star system, billions of years old. It's the rarest kind of comet, a visitor from somewhere else in the galaxy. There is a place in our galaxy so cold it breaks the rules of the universe. Not a black hole, not deep space, but a nebula colder than the vacuum of the cosmos itself. The Boomerang Nebula drops to minus 458 degrees Fahrenheit, even colder than the cosmic background left over from the Big Bang, which sits near minus 455 degrees Fahrenheit. By physics standards, nothing should drop below that universal temperature floor. So how does a nebula cheat the universe? Its dying star ejects gas at over 330,000 miles per hour, expanding faster than anything around it. Rapid expansion rips away heat faster than radiation can replace it, creating a natural freezer more extreme than any temperature the universe normally allows. For now, it stands as the coldest known region in existence, a scientific paradox floating in plain sight. If a nebula can break the universe's temperature limit, what other impossible physics might be hiding out there? There's a hole in the universe, so vast and empty, scientists call it the Great Nothing. It's a cosmic void known as the Boots Void, stretching 1 billion light-years across. And to understand how big that is, our entire Milky Way galaxy is just a speck by comparison. Inside this region, there should be tens of thousands of galaxies, but there are only a handful. It's like the universe forgot to put anything there, or something cleared it out. Some astronomers suggest its many smaller voids merged together, forming one colossal emptiness. But there's a darker idea. What if it marks the place where a different universe once collided with ours? A cosmic impact so massive, it erased entire galaxies before they could even form. We can't go there. We can barely even observe it. But every time we point our telescopes at that direction in space, we're staring into the largest known emptiness in the universe, and no one knows what's hiding inside. Hidden across the galaxy are stars so luminous they pierce through dust, gas, and entire nebulae, beacons of power we still don't fully understand. Here are the 5 brightest ever discovered. R13601. In the Tarantula Nebula, shining 8.7 million suns. It's so massive astronomers don't fully understand how it holds together. WR102, a Wolf-Rayet star blazing at 10 million solar luminosities, with temperatures over 200,000 degrees Fahrenheit, shedding itself into space. Eta Carinae, about 5 million suns, but during its great eruption, it briefly became one of the brightest things in the sky. It's unstable and could explode in cosmic anytime. LBV 1806-20, a hypergiant blazing at roughly 40 million suns. If it replaced ours, Earth would vaporize instantly. The Pistol Star, releasing in 20 seconds what our sun outputs in a year. Near the galactic center, wrapped in a cloud, it blasted off long ago. Everything you can see in the universe, stars, planets, gas, and dust, makes up less than 5% of everything that exists. The rest is mostly dark matter. Dark matter doesn't glow, reflect light, or absorb energy. It doesn't interact with electromagnetism at all, which is why it's completely invisible. What it does do is interact with is gravity. When scientists measure how fast galaxies rotate, they find something impossible. There isn't enough visible matter to hold them together. Without extra mass, galaxies should tear themselves apart. That missing mass is dark matter. The leading idea is that dark matter is made of unknown subatomic particles, particles that rarely interact with normal matter and pass straight through it. Billions of them may be moving through your body every second without you ever noticing. Dark matter also forms a massive invisible framework across the universe. Galaxies form and move along this structure, shaping the cosmos on the largest scales. We don't know what dark matter is made of yet, only that without it, the universe wouldn't look anything like it does. What actually happens at the edge of the observable universe? When you look at the night sky, you're seeing only a tiny bubble of the cosmos, about 46 billion light-years in every direction. Not because space ends there, but because that's as far as light has reached us since the Big Bang. So what's at the edge? It's not a wall. It's just the limit of what we can see. Beyond it, the universe keeps going, maybe forever. Galaxies past that point are moving away faster than light because space is expanding, so their light will never reach us. That edge is really a cosmic horizon, a cutoff where information disappears. And here's the wild part. Everything we observe, every star and galaxy, is likely just a tiny fraction of the real universe. Some scientists think it's infinite. Others think regions beyond our horizon could have different physics, maybe even different realities. Whatever lies past that edge, it's out there. We just can't see it yet. Different physics, different stars, maybe even different realities. Imagine an ocean so deep it makes every ocean on Earth look tiny. And it isn't even on a planet. It's on a frozen moon orbiting Jupiter, and its name is Europa. Beneath Europa's bright cracked shell of ice lies a global ocean, possibly 100 kilometers deep. That's more water than we have on Earth. What keeps it liquid? Tidal heating. Jupiter's immense gravity stretches and squeezes Europa, warming it from the inside like a cosmic furnace. And here's where things get wild. Scientists think this ocean might be in contact with a rocky seafloor, the perfect setup for hydrothermal vents. Places where life could form even without sunlight. Life that breathes chemicals, glows in the dark, and never sees the surface. We've even seen hints of plumes, giant geysers shooting water vapor into space. If those are real, we could literally fly a probe through them and test for life without drilling a single hole. Europa might be the best chance for alien life in our entire solar system. So the real question is, what will we find? The most violent thing in the universe isn't a black hole. They're called gamma ray bursts. These events occur when extremely massive stars collapse under their own gravity, or when two neutron stars collide after orbiting each other for millions of years. For just a few seconds, they release more energy than our sun will produce over its entire lifetime. That energy is focused into incredibly narrow beams traveling at nearly the speed of light. Because of this, gamma ray bursts can be detected from billions of light years away, making them some of the most distant objects we've ever observed. Astronomers often describe them as cosmic flashbulbs. As their light passes through space, it reveals information about distant galaxies, star formation, and the conditions of the early universe, long before our solar system even existed. Most gamma-ray bursts happen in galaxies very different from the Milky Way, and they're usually aimed far away from us. Earth has quietly orbited the sun for over 4 billion years, without ever being affected by one. So when scientists detect a gamma-ray burst today, it isn't a warning. It's an opportunity to watch the universe pushing physics to its absolute limits. Imagine a world where storms don't bring rain, they bring sapphires. That planet actually exists, and its name is HATP 7b. This ultra-hot gas giant orbits so close to its star that one side is locked in permanent daylight. Temperatures climb above 4,500 degrees Fahrenheit, hot enough to vaporize minerals right out of its atmosphere. Those minerals drift to the cooler night side, where they condense into aluminum oxide crystals, the same material that forms rubies and sapphires on Earth. Enormous winds, faster than any hurricane ever recorded, whip these crystal clouds across the planet and trigger violent storms that make gemstones fall sideways at thousands of miles per hour. Some scientists even think the contrast between the day and night sides creates massive shifting weather cells, unlike anything in our solar system. If a planet can have sapphire weather, what other impossible storms might exist across the galaxy? And make sure to check out the description for facts about this planet. Imagine a planet where it rains glass. This world is called HD 189733b, a massive gas giant orbiting so close to its star that its atmosphere is superheated to over 1,700 degrees Fahrenheit. But the heat isn't the scariest part. On this planet, winds race around the globe at more than 5,000 miles per hour, over 7 times faster than a Category 5 hurricane on Earth. At those speeds, the clouds aren't made of water vapor. They're filled with silicate particles, the same materials that make up glass and sand. So when storms form, it likely rains molten glass, sideways, driven by those relentless winds. Astronomers figured this out by studying how the planet's atmosphere absorbs and scatters blue light, revealing powerful jet streams ripping through its skies. So the next time Earth's storms seem intense, remember, some planets the weather is far, far worse. Make sure to check the description for much more information on this insane planet.